Our next property is the associative property. And this one says a binary operation O defined on a set S, A, B, C, and so on is said to be associative if all S, Y, Z belongs to S. So here is S, Y, Z. Okay, that's what you pick. Now S, Y, Z is in the set, and this set is what also belongs to raw numbers, right? That's what belongs to S. Good. Now we are saying that S operation Y bracket close times operation Z is the same as S operation times bracket open Y operation Z. This is what we are saying. So let's represent this on a diagram and see our diagram. This is our diagram here. So as I said earlier, this is our operation box, the operand. Okay, our operand is here. So S is entering first, then Y is entering. That's why I said S operation Y here. It gives us S operation Y. Operation sign here is O Y, right? So S operation Y. This is it. Now we already have S operation Y here. So S operation Y will enter. Then we have another Z here. It's also entering here. Since S and Y has already been mixed, now we have S operation Y, and this one, after solving S operation Y, now Z is also entering. So we can solve them together. So this one can also mix. That's why we have S operation Y multiplying operation Z. The same thing applies here, right? Here, we have S here, but the S is not entering first. It's Y that's entering, and Z, they are entering at the same time. That's why we have Y operation Z before the S will come. So when we are solving, we will deal with the bracket first, okay? So then S operation times Y operation Z. Therefore, we get S operation times Y operation Z. So this is how it is, okay? Associative property. Let's take note of this. So addition and multiplication of real numbers are associative. So let's start from addition. Reason why we say A plus B plus C is same as A plus bracket open plus B plus C bracket close. So we are saying that 6 plus 4 here. Then the answer that we get, then we add it to the 5. You will get 15. This is what, if you add all of them, this is what you get. Then we come here, 6 is outside here, and this one 4 plus 5. So we put them together again, you will get 50. That's why we say that associative property of addition is associative, right? Now with the multiplication, good. We said A times B the same as A times B times C the same as A outside times B into bracket C. Good. So 2 times 3 bracket close times 4. So like I said, we shut the bracket first. So 2 times 3 is what? 6 times the 4 here, we get 24. Like we did with addition of what? Associative property here. Good. Then 2 times bracket open times 3 times 4. So 3 times 4 here, you will get 12. Then multiply by the 2. We still get what? The 24. So we can conclude that multiplication is also associative, right? Associative property. We solve example under this. So we solve example here. So this is our example. Given that operation is defined on the set of raw numbers, S operation Y equals this. That's the definition here. We should evaluate this and evaluate this and show that this operation is associative. So by definition, so here the associative property is an SY. But we have three variables, right? So we should add one to it. So it will be s operation y all times what? Z operation z, right? So this is what we are saying. Now I 4 operation 3 times operation 5. Like I said earlier from our diagram, we saw the one in the bracket first, it will enter. So now this is our s, this is our y, right? So anywhere you see s, just put 4 there. Anywhere you see y, just put 3 there. In our definition, s plus y, this is what we are going to s plus y plus sy. So s, y, s, y. So anywhere you see s, just put 4 there. Anywhere you see y, just put 3 there. And this is what we get, operation 5. Now, the whole of this is what? Our s, and this one now become our y. So this one we can just add them. So if added, we get 19 operation 5. So like we said, how we did it earlier, 19 operation 5. And we said that the is s operation y. So here, the 19 is now our s. And what? The 5 here is now our y. So whenever you see s, again, just put 19 there. Whenever you see y, just put 5 there into this definition. So this is what we said, right? So s, y, s, y. Then it's what? 119. That's our final answer. Now, 4 operation, bracket 3 operation 5. Good. With here, the same thing. We would deal with the one in the bracket first. So, we will do the one here, okay? S, Y. So whenever you see just put 3 there. Whenever you see Y, just put 5 there. Let's do the one in the bracket. So for operation this, so you are doing the one in the bracket. So S, Y, S, Y. Now this one we can add them straight, right? So if you add them for operation 23, we get the 23. Now our 4 here are now become, because that's what the first one. So now it's now our S, and this one's our Y. So we just substitute it again. S into this, right? That's what we are doing. So now it's for 4 plus 23 plus 4 times what? 23. As easy as that. Therefore, you add them, you get to 119. So they are the same. So this one is even associative. So I showed that this operation is associative. Okay, so we should show that the operation is associative, and we say that if the operation is associative, if this equals this, right? So we talk about this in our definition: s operation y times operation z, s operation or bracket y operation z. We talk about that one in our definition. So s operation y bracket code times z, like we did earlier, we will do the one in the bracket first. So this one sy. So anyway, see here, just put it. So this is just our definition. So it will be s operation y. So you know that. Now we are done with this. So the whole of this now our s, and this one is our z, right? So the whole of this is s, and our z here is now, our y here is now z, right? So like s operation y. So the whole of this is s. Then our z here is y. So we will just have to into this definition. So anywhere you see s, just put the whole of this there. Anywhere you see y, just put z there. So the first one is s. S is first, right? So this is our s. The whole of this is our s. Plus our y. Now our y is what? Z. So plus what? Z. Then plus s times y. So the whole of this times what? Z, because z is y. Good. So let's simplify further. For this one will be the same plus this. Then multiply the z. So this one, this z is multiplying the whole of this. So then we get sz yz plus syz. So that's our equation, the first equation. Now let's move on to the next one. S operation this times y operation z. So like we said, we do the y with the bracket first. So here is our what? S, and here is our what? Y, right? Into the definition as we are comparing. So anywhere you see S, just put Y there. Anywhere you see Z, just put what? Anywhere you see Y, just put Z there. So This is what we are saying. We are just going to substitute. So S operation this is what we are saying. So sy. So y z. So we just substitute. So anywhere you see s, just put y there. Anywhere you see y, just put z there. That's the definition. Simple. Now s operation the whole of this. So now this is our s, right? Now y is the whole of this has now become our y. So s operation y, right? So whenever you see s, just put s there, and whenever you see y, put the whole of this there. And the definition was s plus y plus sy. Okay, so our s is s, like we said earlier. Good. Plus our y, the whole of this y from our definition. Then plus sy. So it means that the s times the whole of this. This is what we are saying. So s times so we can simplify further. Our s maintain this one, then multiply to by our what? S. Good. So from here we can compare. Yes, if compare, so let's make it nice. Let's make it better. Example this. Okay, so we can compare. As we are comparing, equation 1 and equation 2 are the same. Therefore, from the equation 1 and equation 2, it can conclude that this is associative. So the operation here is what? Associative. As easy as